Welcome. Today we're going to talk about Pandas series. Series is, one of a couple of data structures within Pandas. There's also data frames. We're not going to talk about data frames, but it's really important to understand series before you dive deeper into data frames. And so series, if you can just think about it visually, is like an Excel spreadsheet with just one column of data. Keep that in mind as we go through this today. I think it'll be really helpful for you. This today is going to be an introductory course. It's for people who are new to series, who've never seen it before, or who are struggling with some of the key concepts with series. Excuse me. So as we go through this today, I'll pull out those key concepts, and we're going to do it at a pace where you can code along with me. And so you get practice, you can be building your own series, and hopefully at the end of this, you're going to be really comfortable just building your own series without really doing a lot of thinking about it. So without further ado, let's get started. So the first thing we're going to do is we're going to import NumPy, and we're going to import Pandas, and I'm going to do it in Jupyter Notebook. That's what I use. So I'll import NumPy, we'll assign it an alias of NP, import Pandas as PD for our alias, and then we'll run the code cell by clicking the arrow to the left. So let's just build our first series and get one out on the table. We'll call this series 1, and we'll first of all pull up Pandas with a PD and type in series. We'll open and close brackets or parentheses, and then we'll do some brackets, and I'm actually going to put some string values in, so I'll use a quote. So let's do some fruit. I'll type in apples, pears, cherries, and then grapes. And then when I run this, I want to be able to see it right away. So I'm just going to type in the name of this series, which is SCR1 underneath it, and hit the code cell. And there we go, our first series. Cool. So what we see here is it does look like that one column in an Excel spreadsheet. We have apples, pears, cherries. So that's our data set, or our data points. And then if we look to the left, there's these numbers, 0, 1, 2, 3. This is called an index. So we are actually indexing these data points. And so the apples has a index value of 0. Pears has an index value of 1. And if we scroll down further below, it says data type or dtype object. So because these are strings, it's inferring that it's just going to be an object. And we will show you how we do some series where we have integers and floats and things like that. But generally speaking, it said, hey, it looks like you got some strings. I'm going to assign this a data type as an object. Okay. All right. Now, whenever I build and learn new things within like Python, I like to pull in the attributes of what it is that I'm building. And we're going to do that right now. And this is one of like the tips that I have when you're trying to learn a lot of the concepts we are, and in this case today's series. So I'm going to bring in SER1, which is the name of our series, and I'm going to pull in and print out endin, which is the number of dimensions. We expect it to be 1, but let's just do it anyway just to be sure. SCR1 brackets 0. That's actually going to pull in the value associated with that index. So index of 0 is going to pull in apples. And we're just going to do that today so you can see how that looks like. We're also going to pull in the type. What is SCR1? And a couple more things. We will print out the values, and we'll print out the index. And let's run this. So the first thing we asked it to print out was the number of dimensions, and you see it has a 1 there. So it's a one-dimensional bit of data, which basically means it doesn't have rows and columns to it, where there's data for the rows and the columns. There's no depth to the data, like a two-dimensional set of data. This is just one dimension. It is simply a row to columns. And that's why it's important when you look at this and you see the index and the columns, don't look at this as a 2D structure. It is a 1D structure. The next we printed out was the series, and we pulled out what the value associated with the index of 0 was, and that's apples. So here's index 0, and that's apples, and we'll look a little bit more at that later. So what is the type? What is this thing that we just built? Well, it's a Pandas series. Okay, we're doing good so far. The next thing I want to identify is the values associated with SER1. Here's the values that we created when we built out our series: apples, pears, cherries, and grapes. And the last thing is the index. We expect to see this index here to the left, and we do. It's a little bit different than what we would expect, but it says range index start is equal to 0, stop 4, step 1. So that basically says you start at 0, the stop is 4, and you'll learn this more as you go along, but just get comfortable with that basically saying you're starting at 0, you're going up to but not including 4. So you have 0, 1, 2, and 3. And then step is how many integers we're stepping by, and in this case it's 1. So that should be fairly intuitive. The next thing I'm going to do is we're going to create a series, and we're going to do this by starting out with a list, and we're going to pass that list into a series. So let's build our first list. We'll call this list 1, and we're going to make this equal to just a bunch of random integers. Type anything you'd like in there. Okay? And then go ahead and print out that list. And you do that just by calling it and running your code cell, and there's our list values, a single array. Let's go ahead and pass this now into a series and make it a series where it has an index to it along with the associated values, and these would be the values: 45, 43, 78, and 43. So to do this, let's call this SER2 for our next series. We'll bring up Pandas for PD and series. And what's the next thing we put in here? A parentheses. And then we're just going to pass in this data right inside the parentheses, and to see what it says afterwards when we run the code cell, just type in the name, SER2, and then run it. So there it is. We have our values of 45, 43, 78, 43, and the associated indexes. The indexes, as you can see by default, are in sequential order, ranged as integers that start with 0. We have our data type of int. So this already kind of looked at the data and said, oh, these are integers. Pretty cool. Now watch what happens if we go up here and we make one of these a float value, 45.0. Go ahead and rerun your cell, and then rerun SER2. And look at that, it changes it to a float. So one of the things, we won't be doing this every time, but you can always just take this, copy it, print it further below, and then, let's see if I can hit my copy key right, and then hit paste, and then put in the name of the series that you called it. By changing these to SER2 and then running it, and you'll see the same things that we saw before. This is one-dimensional. We pulled in the indexed value of 0, which is equal to 45. This is a Pandas series, and so on and so forth. Okay, so one of the next things I want to show you is that we can actually label our indexes. We don't have to have these be 0, 1, 2, and 3. And that's a good thing to know, because often series is used for things like date and timestamps. And you won't necessarily see series listed with these integer values. They could be date and timestamps or other things, but let's just play around with this and show you that we can actually label our indexes. And we're going to call this a labeled index series. So we'll call this SCR3. What's the first thing I put here? PD for pandas, because we want to call up that package. And we're going to call this a series, pull up the series function, and we'll put in our parentheses. And let's put in some float values. All right, let's just say for grins, we've measured our kids' growth rate every month, January, February, and March in 2021. All right, so let's say in January they were 56.4 inches. In February they were 57, little growth spurt. And then in March they went up to 57.5 inches. Okay, so the way to label your index, you put a comma there to separate out your parameter, and we're going to call index, make that equal to the index values. And I'm going to start out with a quote because these are going to be strings. We want to pass in like 2021, for example, February 2021, and then March 2021. So it's important to note here that if you have three values here and you're building your own labeled index, your labeled index, the number of index labels here has to match the number of values. So we have three labeled indexes and three values. And I'm going to go ahead down here so I can see what this looks like and type in SCR3 and run it. And there it is. Check it out. There's our column of data, 56, 57, 57.5, and here's our labeled indexes, January 2021, February 2021, and March 2021. And see where it inferred that these values are floats. It went ahead and changed the data type to a float. Okay, so another helpful thing, if you're typing all this stuff out and you're going, okay, what do I call this stuff? What are these parameters that are in here? Help is, has always been my best friend. There's a number of ways to pull up help. I'm just going to show you this way, which I do pd.series, basically pulling up what it is, the function that I'm running in here. And I run the code cell, and I draw my eye generally to the first 2 or 3 sentences here. And this one is kind of telling me what to put in there. As you can see, here is series. We know what that looks like because that's equal to this value here. And then we start with parentheses. Here's our parentheses, and it's calling for the data, index, data type. So to find more details about this, you can scroll down further. Let's just look at one of them. Let's look at like the data type. It says index equals none, or I'm sorry, data type is equal to none. And then scrolling down further below, let's just read it. Data type. Data type for the output series. If not specified, this will be inferred from data. Oh, well that's interesting. So it inferred it from the data because we had put floats. Okay, that's cool. The last thing I want to point out is, let's look at the index. So index, it says, is equal to none. Scroll down and let's just read the first part of this. Values must be hashable and have the same length as data. Well, we talked about that earlier. It has to have the same length as your data. Otherwise, it's going to error out. Where it says values must be hashable, hashable is a value which never changes it during its lifetime. So that index is going to stay there with that value unless you go in and rerun your series. Which you can do here. You can change the index just by rerunning this. But generally speaking, it's considered hashable because that basically lives and stays with that value. And there's some benefits and reasons why that is, and that's a whole nother discussion. But nonetheless, just keep that in mind. Okay, so let's go ahead and pull out some values by indexing. Let's say we want to pull out the value of 56.4, which is associated with the label, the index label of January 2021. How do I do that? To do that, we just go ahead and type in what we've named our series as, which is SCR3. our variable, and we use brackets. The bracket notation will say, hey, what do you want to pull out? And I'm going to put a string in here because these are string values. If it was just a value of like 0, 1, or 2, I would just be placing a 0 in there. Very similar to what we saw when we printed out that first series we built. Remember, we put SER1 in brackets and we put a 0, and it pulled out apples, as we saw right down here. So we don't need a quote or set of quotes here because that is an integer value, but we do down here because it's a string. So let's put in the string of January 2021 and go ahead and run that. And there's our value of 56.4. Subsequently, we can actually still index this as well using integers. So if we put SER3 and type in 0, we still come out with 56.4 because behind the scenes it still knows that it's indexed at 0, but we did have a label for it. Okay, so we're going to build another series here, and we're going to do something interesting where we're going to broadcast out a value. You'll hear the word broadcast a lot. Let me show you an example of that. So we won't create a variable for this, we'll just run it. And so we'll type in pd.series, and let's say we want to broadcast out hello. So we open up our parentheses, hello is a string, so we type in hello. Now what's kind of nice about this is broadcasting allows that value to be placed in however many values it is that you're trying to create. We're going to index using a range of like 1 to 10, which will pull in 9 values. Let me show you this. So we'll index, it's equal to a range 1 to 10. And basically what this says is that we'll create our index. What the index is going to be is a range of values, and we're going to do the range of values from 1 to 10. But remember with Python and using this environment here, it's just going to print out a value between 1 to 9 because it's 1 to 9 and it excludes this last value of 10. All right, so let's go ahead and run this. And there we go. We've just broadcast out hello 9 times. This is a data type of object, and you all know why, right? It's because we passed a string value. And that's why the data type ended up being an object. So how would I take this and let's say I want to create a data type of integers. How would I broadcast integers? So let's say I want to broadcast out the value of 10 and I want then the data type to end up being an integer. So pause, go ahead and take the same thing and make the change, and welcome back. So all we have to do is come up here and change the data from hello to 10 and run it. And there we've just broadcast out 10, and now we have a data type of integers. Okay, cool. All right, so let's go ahead and do a little bit more with pulling values out using indexing. We're going to do another series of data with strings, but we'll do something interesting with this. We're actually going to slice the data, okay? And I'll show you what we mean by that. So let me go ahead and we'll create a series called family, and I'll input, let's build an array. An array is not going to create a labeled index or an integer of indexes. So if you're familiar with NumPy, an array is great. If you're not, highly recommend you just take a few minutes to understand NumPy and arrays, because it's another important part of this whole understanding like data structures and how things work within Python. But we'll create an array. I'll start it with parentheses, I'll do some brackets, and I'll put in the names of some of my family members. Linda, Matt, Cami, put myself, and I'll put one of my dogs, Flint. So let's go ahead and run this. And there's our array. Now, let's pass this array into a series. Remember how we did that before? We typed in pd.series and we passed in the variable which in the previous case had a list. In this case, we're going to have an array. So we'll create ser for series, and we'll call it family. And I'll type in pd.series, and I'm going to pass in family. Okay, before I run this, I want you to think in your head what you're expecting to see. A single column of data, and the column of data is going to have these values here. And because we didn't pass any indexes, or labeled indexes, it's going to start with 0, and then go to 1, and then to 2, and then to 3, and so on, right? So let's go ahead and run this. And the reason why that didn't pull up is because I forgot to name it correctly. So it's called ser family. So go ahead and run it again, and there we are. That's exactly what we expected to see. And we have an object again because we're passing in strings. Okay, so let's go ahead and quickly pull out Flint. So the way to pull out Flint is we're going to type in SCR family, put my bracket in there, and I'm going to put a value of 4, and there's Flint. And we can do the same thing by pulling in Matt, who's going to be indexed at 1, and there's Matt. Okay, so we've got that down. Okay, so now we're going to do something really cool. We're going to slice it. So we're going to pull out just specific values based upon the index. So let's say we want to pull out Linda, Matt, and Cami. The way we do that is we go ahead and type in what the name of our series is, and this is SER family. We know that we need brackets because we're going to pull out values based upon the index. And we know that Linda is 0, and then we're going to go on up through Cami. We want to include Cami, so that means we're going to pull up the index 0, 1, and 2. And so the way that we note this is we're going to go from 0 to 3, which basically means start at 0, go all the way up to but excluding 3. And then when you run this, you'll see that we now have Linda, Matt, and Cami. Okay, so what I encourage you to do is build a number of series, play around with the indexing, and get comfortable with knowing how to pull different values out using just a single index value or using slicing notation. You know, I could just as easily said I want to go from Matt and go to Flint, and that would be as easy as going from Matt is number 1, and then going up to Flint, he's number 4, so that means we want to include 4. We go to 5, and then we run that, and then we go Matt, Cami, Tim, and Flint, and it excluded Linda. Okay. So now we're going to do something really fun. I don't know if any of you noticed, but at the very beginning, you may have read that lastly we'll end up slicing through a dinosaur dictionary using your new skills. All right, well, dinosaurs, because I think dinosaurs are fun. But here's two key concepts we're going to make sure you understand: slicing and dictionaries. We kind of, already talked about slicing. We sliced, the names of family. But what we didn't discuss was dictionary. So let's go ahead and scroll down. I've already created this. So feel free to pause if you want to copy exactly what I wrote, or if you want to create your own dictionary. If you want to create your own, pretty easy. You just go ahead and type in dictionary 1 or whatever you'd like to call it. Place your equal sign in there, and then use like the curly bracket notation. So open and close with curly brackets, and then dictionaries are a key value pair, meaning that you start with a key and then you end up with the associated value. Okay? So think of like a dictionary. You would open up and try to find a word, and you scroll through the pages and you go look for a hadrosaurus. So a hadrosaurus would be equivalent to, finding the name, hadrosaurus within the dictionary, but this ends up being called the key. The value would be like the description of hadrosaurus, and in this case it's the official state dinosaur of New Jersey. Like, who would have known? So anyway, so type in some keys. I would do list 3 or 4. Make sure that if you use keys that are strings, that you put a single quote around it. So you enter your key, you input your colon, and then after the colon, you can input the value associated with that key. And here, I just put some strings, and you don't have to worry about the spacing between the colon and, in this case, the string value, because this coding environment doesn't care about spaces. It does care about tabs, and that's another discussion. So don't worry about having it spaced perfectly. I just kind of like to look nice. That's why I spaced it over. For those of you who are really looking at this, you'll notice that something's a little interesting on the right-hand side here with these values. The first one has a double quote around it. See that? And see that. But the rest of them don't. I want you to pause and try to figure out why that has a double quote around it. Okay, so the reason is because this string value has a single quote value in there, or an apostrophe. And so it gets a little messed up if you try to run this with single quotes. You'll actually error out, and I'll show you that right now. It says invalid syntax. In fact, let me remove that other single quote at the end there. Sorry about that. And it's still invalid syntax. So when you see stuff like that, and what's kind of nice is this pointed right exactly where the issue was, and it went to North Americas, and it said, hey, there's something wrong with that. So in this case, we know that it doesn't quite know how to code this out or read this out, so you put double quotes around it, and that will actually fix the issue. I'll rerun it again, and there we go. All right, so let's go ahead now and print out dictionary 1 and look at the values. Okay, we're doing good so far. Now what we want to do is we want to pass this into a series, and you guys have probably remembered how to do that before. So I'm going to go ahead and do that now with you all. We'll call this dinos is equal to pd.series. And what are we going to put in here? Dictionary 1, because that is what we're trying to pass into the series. And if we want to see this after we run the code cell, we just put in dinos and we run it, and there we go. We now have our column of data, which in this case is our values. And then in the dictionary, these were the keys. These are now our indexed labels. So I want to show you something which is interesting and also helps you build intuition around this. You can actually index a dictionary. So remember, dictionary 1 is the dictionary, dinos is the series. So let's index dictionary and pull in one value, but then I'm going to show you an issue with slicing. Okay? So we'll type in dictionary 1. We'll put in our brackets, put in single quotes, and let's say we want to pull up Hadrosaurus. And when we run this, what are we going to get? We're going to get the value, which is going to tell us this string of words here, which is the official state dinosaur of New Jersey. Okay, pretty cool. And we can do the same thing with dinos, right? We can index this. Let me scroll up here for you guys a little bit. So there is dinos, and we pull in Hadrosaurus, and voila, there we go, same thing. Now, but I want to show you something when I try to slice. So let's grab dictionary, pull up the same thing, and remember slicing is where you're pulling values from and to. So since this is the last item in the list, we're going to put that colon in front of it, and let's say we want to slice it from, you know, this first one, Acrotholus. Hopefully I said that right. And we'll put our single quotes around it because it's a string, and we'll run this, and we get an error. It's because we have an unhashable type for the slice. So we learned that hashable, and we learned about what that was earlier, if you recall. It's where, you know, the index stays for only the life of that series. But in this case, it's saying that this is not hashable. So just, you know, a quick note, when you run into things that are errors, and you're going to see this all the time, and the system decides to, you know, argue with you a little bit, what I generally do is scroll down to the very bottom of that, what it is it's telling you, the argument, the error, however you want to call it, and just read it. And often it'll tell you what the problem is. But we won't have that problem if we try to do the same thing with a series, because we know we can slice through a series, right? So let me go ahead and change this to the name of Dinos, which is our series. And we'll run this, and there we go. We can slice through a dictionary of dinosaurs. How cool is that? Okay, so I guess the last thing I want to show you is where we can do multiplication, division, subtraction, and different things on series, and this is really important. So why don't we start out by just getting a random set of numbers and passing those numbers into a series. So this is, you know, gets a little past beginner level, but let me go ahead and do this for you. Feel free to run along, and I'm going to explain this code or follow along. So we're going to start by seeding the data. And what the seeding does is whatever I run in the rest of this code cell, if you input that along with me, you're going to get the same exact numbers. If you don't care about getting the same exact numbers, you actually don't have to input this line of np.random.c. But you do, if you want to follow along, put the number of 43 in there. Okay, let's go ahead and build a series. We'll call it series 5. And we're going to pull up series and our function here, and then we will bring in for our data just some random numbers. In fact, sorry about that, I'm going to pull this in from NumPy. So NumPy has a really cool function, random, with a method of random int, which allows you to build these really cool arrays of different sizes that use integers. But this particular function and its method are allowing you to pull in a range that's one-dimensional. I do have a video that shows you how to do arrays with a NumPy and build single and multi-dimensional arrays, so feel free to jump over to that other video if you want to see more details about that. But we'll type in numpy.random.randint for integers, and we're going to pass in 1, 99, and 5. And I'm just going to run it, and then I'll just tell you quickly what this is doing. So first of all, we called it SER5. That's why I printed out with this at the very end there. PD.series is we're using Panda and we're using and creating a series. And inside of this is the data. So that's like that first argument within a series that we saw that said data. Go back to the help menu and look at that if you don't recall. We're going to pass in and use NumPy. Pass in a function in the method of random.randint. And if we pull the help menu up specific for that, np.random.randint, you'll actually see more information about it. But what this is basically saying is randomize numbers from 1 to 99, and I only want you to print out 5 of them. That's what that basically says. So here they are. So let's say we want to multiply this series by 5. Okay, let's go ahead and print out. You don't actually have to write print and put this in parentheses, but I'm just doing it to show you another way you can print things out. So we do SER5 and then we multiply times 5. What do we expect to see? 5 times 69, 5 times 65, and that's exactly what we ended up with. So what would happen if we did it 5 times, or 5.5, SER times 5.5? Right now this is showing it as an integer. I'm assuming that that's going to change it to a float value. And it does. Because remember, the series infers the data type based upon the arguments that you have in there, and it's inferred it based upon the fact that you now have a float. Okay, you can do other things in here too, like divide. We take SER5 divided by 10. Okay. The last thing I want to show you is probably an important one, because actually it is important. It's using a boolean, and we're going to broadcast a value and create a boolean set of values. Now you're going to see this a lot, especially if you embark into data science or anything with Python. Boolean values are really important for a number of reasons. So if you've never seen it or you're new to it, definitely get comfortable knowing how to do this. So let's create another series. We'll call it series 6. And let's create an array this time. So why don't we call it array? Because I want to show you that you can actually multiply arrays that you don't build with series, and multiply an array with a series. So we'll call it array 6, and we're going to make that equal to, we'll call it numpy dot array, and we'll do our brackets, and we'll just put in all 99s. And then we'll go ahead and print that out so you can see what that looks like. Okay, so we got an array, and we also got SER5, which we'll use to do some interesting things with. So remember SER5, we'll just print that out real quick, is these values right here, 69, 65, 50, 22, 59, and these are integers. And our array is just a value of 99s. So let's start out with, oh goodness, let's go ahead and multiply them just real quick before we dive into some interesting things. We'll go SER5 times array 6. Okay, pretty cool. So that works. Now I want to show you something. You may have heard of the word condition. Condition is where you build, a condition around, what it is that you're trying to produce. And in this case, we're going to build a condition where we're going to look for values that are above 6,800, for example. All right, let's try this again. SER5 times array 6. Here's our condition where it's greater than 6,800. Let's go ahead and call this condition and set that equals to this value. So what can we expect to see when we run this? We're expecting to see just one value come back. Interesting, huh? We've got a Boolean value. We've got this indexed item at 0 with a value of 6831, which has a value of true, but all the other ones have values of false. Okay, this is really important. I would definitely play with this a bit. Feel free to do conditions and what have you, but just notice when you use the condition in this case and the Boolean value comes back, this is going to be very, very popular in a lot of things that you do as you move forward in data science. Okay, so we'll do a few other interesting things. You can pull the mean of a value, do a little bit of descriptive statistics. And there's our mean of SER5, which is this right here. These values here have a mean of 53.0. Okay, so one more thing to show you. And this is a really important one too. I'm going to take a couple of series, we'll build it together, where we have series that don't necessarily match up when we add the two series together. And they don't match up based upon the index. And when you have that happen, you're going to get some values that say something like capital N, small a, capital N, or NaN. And you'll see this often, especially when you start working with data in real life, using Pandas or Python or what have you. You know, a lot of data in the real world is going to have missing values and null values. So it's important to start getting a good understanding around the concept of nulls and how it is that they're created, why are they there. Again, probably definitely a whole nother video to go over those types of things, but let's just get your feet wet into that area. So we're going to build two series, we're going to add them together, we're going to make sure the indices when we add them don't necessarily match up, and then we're going to get some interesting results with null values. So just trust me on this, this is definitely an important one. We'll go ahead and build two series. We won't make this too complicated. We'll call this series 7, and we'll build another one called series 8. Okay? Put your equal sign in there. And the first series is, let's go ahead and let's just put in values of like 1, 2, and 6. Okay? And we're going to create an index and we're going to label it. Okay? Let's do a label of USA, France, and Germany. And I would recommend you follow along with me and input this stuff because you'll understand the, what it is that I'm trying to explain if you can input it how I am. So we'll create our next series as 3, 4, and 5. And again, these are just the values. And then we want to create our index. Now notice I didn't actually put the value of index as equal to this. Why is that? Let me just show you real quick. I want to help make sure you guys are getting the benefit of understanding why things are done the way they are. So I'm just going to pull up help. Help pd.series, and you'll see that in the series it's asking first for data and then for index. So if you input things in the order that they are when it's explained in this help, then it's not going to come back and argue at you. So for example, I could have done the same thing, like said data is equal to and index is equal to, and this would still run. In fact, we'll run this one this way and we'll run the next one without implicit or explicitly implying what that parameter is. Okay, so the next one we will do the index of, we'll do USA again, we'll do France, and this time we're going to bring in Italy. And actually, this is good to note. If you notice on the screen, Italy has it's in black colored font as opposed to USA and France, which is in red. Often your eye is going to get used to drawing it to is like, oh, hey, something's not quite right here. And in this case, I forgot the single quote on the other side of France. So I'm going to go ahead and run this, and let's print out these two series. Now, if you want to print two series together, so it's kind of easy to read, this is how I've been doing it. I go print, I'll put in the first series, I'll do print with nothing in it because then it gives it a space between the next series, and I'll do SER8. And there they are. USA, France, Germany. These are the labeled indexes, and they're different. We have USA, France, Germany, and then US, France, and Italy. And then we have the values here. So what happens now if I add together SER7 and SER8? Remember, when I'm adding it, I'm not adding it based upon the labels. I'm adding it based upon the values that are associated with the labels, the data values. So adding will work because this identifies these as integers. So it knows these are integers. If you hit add, theoretically it works, right? So let's do SER7 plus SER8. Okay. Here's what's important here. France worked perfectly, right? So France had a value of 2 and a value of 4. Those two together is equal to 6. And go back up here. Here's the values for France, 2 and 4 in what we input when we created this series. Okay, no big deal. So Germany, we got an NAN because it basically said, hey, I know that you want to add me. I see Germany in this first series, but I don't see Germany in the second series, and so I think I'm just going to come back and tell you that we have a little bit of a problem here, and this ends up returning back a null value because it can't add it. There's no value to add, and so it returns it as a null value. So I'm just kind of pointing that out because, again, as you go further into your learning about this stuff, understand null values. When you start seeing those things, pay attention to them, understand why they're there. And then, of course, there's a whole nother set of understanding and videos about how to fix these things, which I plan on doing because I like this stuff. All right, so I think I'm going to go ahead and end this and just kind of give you the key takeaways. The first thing is, series, is like a type of list in Pandas. It can take integer values, it can take string values, float values, double values, pretty much any type of data type. It's much more flexible than a NumPy array, because remember, NumPy arrays have an implicitly defined integer index. But when you go to the Pandas and series, you get to see it, you see the data type, and you can actually change those values of the index yourself, as you saw. So it's pretty cool. So series has a lot more flexibility in essence than a NumPy array. And then I guess as we think ahead, the next step for you once you kind of get this down is, go through other videos, watch other people who are doing series, and just see it from different people. The way I try to do things is I try to give you examples that are different than what you might see from everybody else if they're following a textbook or what have you. I give it to you as how I've learned it, that I see it in my head. But get series down, and then if you want to take it to the next step really is to move this learning now into data frames. If you're still struggling with series, then what I highly recommend is jump and look at NumPy. Look at NumPy arrays, look about how they're built, understand those, and then move forward into series and then move forward into data frames. Anyway, I hope this was helpful. Have a fantastic day, and thank you very much.